Right, so now we want to look at the concept called EDA, or Exploratory Data Analysis, which is a very important aspect when you are working with data. Right, when you are working with data, you want to analyze data. There are some techniques that you need to use, right, as you explore the data. Because when you're mining data, sometimes you are trying to look for information that you don't even know exists. You are going to be looking at some patterns that you didn't even know existed, right? And those patterns can also be of great value. They can enhance the data, and they can enhance decision making, such that at the end of the day, management will have enough information that they can use to make particular decisions that can end up being making the company a very profitable organization, right? So that's the reason why. So we are going to be looking at frequency tables, two-way tables, two-way table joint probability, two-way table marginal probability, two-way table conditional probability, and also correlation, a relationship between the columns, the variables, right? That's what we are going to be doing. Or in other words, in other books, those columns are referred to as features, right? So sometimes you find them referring to correlation of features, trying to find the relationship between features within a particular data frame, right? We are not going to discuss this. We already know this, right? Already know this. We are just importing Corolla there, and then we are making a copy of the data set. Then now we are going to define what frequency tables are. Frequency tables, we use the syntax cross tab, right? And they are used to compare a simple cross tabulation of one or two or even more factors. So by default, it computes a frequency table of the factors. So let's see how this works. Right? So here what we are doing is we want to look at a cross tab for one particular column, which is fuel type. Frequency table, it is just going to show us the frequency of each and every fuel type that we have in this column. Remember, we have CNG, diesel, and petrol. So frequency simply means how many cars use CNG, how many cars use diesel, how many cars use fuel. That's what we're going to do. And we're also going to be dropping now values. So drop NA, that's the parameter that is used. So if the parameter is set to true, it simply means in this exercise we are not going to include what? Now values. So if you run it, you get, and those are the values. That's what you're going to get. So which means we have 1,171 cars zinoshandisa fuel. Then we have 137 cars zinoshandisa diesel, 13 cars zinoshandisa CNG. Then here takuta two-way table. Here we want to look at the distribution of gearbox with respect to fuel type. Kuti isusu tiri kuti imota ngani dziri automatic dzinoshandisa petrol, imota ngani dziri manual dzinoshandisa diesel. So that's the type of information that we want, right? So if you cross tab, you write it like this. Index simply means column, rows, and it. So it means rows kwedu tichaisa automatic, and rows kwedu rows ndoka tichaisa kuti 0 means automatic. This row name automatic cars, this other row is for manual cars. Then my columns are going to be represented by the fuel types. Then we're going to drop my now values as usual. So these are the columns. So my columns do fuel type. My columns are. Then my rows are this one is manual. So we have got 12 manual cars that use CNG. We have 137 manual cars that use diesel. Then auto, you see that we don't even have an automatic car that uses diesel. We have fewer automatic cars. Generally, we have fewer automatic cars. Generally. So you see, as you explore the data, you are beginning to see some of these insights. By simply looking at an Excel spreadsheet, you may not get this information. Now let's look at a two-way two-way table, a joint probability. So joint probability is the likelihood of two independent events happening at the same time. Two independent events happening at the same time. So zvatoda kuita panapa toda kuona kuti event yekuti tinosangana ne-automatic car handiti iri CNG, what's the probability of getting that? Probability of getting a diesel car iri automatic iri diesel. Probability yekuwana manual car iri petrol ichi. That's simply what it means. So the difference between imwe yataita ye two-way ndeyekuti for joint you now introduce another parameter inonzi normalize, right? Another parameter. You just introduce another parameter inonzi normalize and you write it in American English. Mukazonyora pana S, your code will not run. So remember, Python was developed by people who are American. So you have to write their type of English. If you write the British English, you begin to face some problems, right? Right. So you see here, the probability of having a manual car that uses CNG fuel is 0.009, and the probability of getting a manual car, the probability of getting a manual car that uses petrol is 0.828917. So this is how we do it. Now we want to look at marginal probability. Marginal probability is the probability of the occurrence of a single event. Occurrence of a single event, kana chingoripo chete taura probability handiti. For example, panapa in this case, kana tanoda kushandisa marginal probability on top of the normalize parameter that we added. You also add another one, inonzi margins, and set it to true. And set it to true. Saka isusu panapa tiri kuti probability yekuti tinotombowanawo motikari ine CNG mu auto nemanual zvese inobva yabuda, which is the same as yatatinayo panapa. But the difference now is we are now adding another column yekuti probability of getting either one of them ichi. And panapa probability of getting either one of them ichi ndoyepana all. That's the difference. And the probability of cars having manual gearbox when the fuel types are CNG or diesel or petrol is 0.797e. So the probability of taking a manual, CNG, diesel, petrol, probability of say it's 1 mathematically. That's correct. Then we want to look at conditional probability, a two-way table in conditional probability. So conditional probability is the probability of an event A given that another event B has already occurred, right? So given the type of gearbox, what is the probability of a different fuel type? That's simply what it means. Saka, what you are going to do here is now, instead of setting the normalized parameter to true, you just set it to what? To index. That's the difference. You just set it to what? To index. Otherwise, this is the same. So this is the same. So these are the conditional probabilities calculated. These are the conditional probabilities. Right? Now, what are we to do next? We want to look at correlation. So correlation is the strength of association between two variables. Right? Strength of association between two variables. So this is an example of the visual representation of correlation using scatter plots. These are just examples and using scatter plots. So the dot core function is the one that we use, and the default correlation method used in this function is Pearson. There are various correlation functions that you can use and methods that you can use, but by default here you know Pearson. But if you want to specify a certain method that you want, maybe you want to use something that is not Pearson, you know what method it goes to, then you assign, you write the name. And so you can just go and research which methods can be used for performing a correlation analysis. Right. So this is how we are going to be looking at these things now. Panapa tinoda kugadzira numerical data. So what we need to do is we want to exclude my object data. So takuti cars2.select data types. So per cars2 to select my data type to exclude that zvine object, such that at the end of the day we are left with numerical data. So let's check the number of variables under numerical data. Takuti numerical data.shape. We want to see how many variables up. So we see 8 columns if been affected, which means 2 columns doesn't name object. Here 2 columns we dropped, but we still have 1436 rows. And then we need to calculate the correlation matrix, right? So to numerical data. Why did we do this? Data is because you cannot calculate correlation yema data type as numerical. You get my errors. So that's why we did this. This is the reason why we did this. We need to understand. So .com, so Pearson's method of calculating the correlation matrix. Correlation matrix. Then correlation matrix so for all the variables. So this is how you interpret it, and tells out what is the strength of association between price and price. Obviously one was price. And then what is the strength of association between price and age? You see, price and age, it's a negative association. So correlation matrix is a number between 1 and -1. And it can be positive. It's from 0 to +1. It simply means there is a strong G, there is a positive association. But if the number goes down from 0 to -1, in that range, it means there is a weak association, there is a negative association. So the negative association can be strong or can be weak, and the positive association can be strong and can also be weak. So in this case, we have got a strong negative G association, which simply means as the age goes higher, age in months, cannot in years, the price is going to go down. And kilometers, mileage gafamba, if the mileage goes through the roof, then the price is going to go down. And you also see let us say metallic color, make a difference of it's even though it's a weak positive, but can find a metallic color, the price is bound to go higher. And then also the weight, if you look at the weight and the price, the more the weight of the car, the more expensive the car is. It's an average, it's an average strength of association. And so this is how we work with correlation matrices. So exploratory data analysis, it doesn't end here. If you open my books, you see there's actually some more you can learn. But for this class, we just did this. But if you've got your free time, you can just go and also explore other methods that can be used to explore data. All right.